And last we have page 3 of our chapter 8 vectors study guide videos. Before I even get started on it though, I want to go ahead and scroll over to 30, kind of due to spacing issues for what you need on number 29. And I don't really like the question. I'm going to go ahead and omit number 30. Okay, number 23. Write parametric equations of the line with the equation 2x plus 3y is equal to 11. So this is like the general form of the equation of a line. If I want the parametric equations, basically what we're doing, talking about our independent variables. In the equation of a line, x is independent and y is dependent. In the equation of parametric equations, t is the independent variable. So if I'm comparing the two, so t is independent. If I'm comparing the two, then my first parametric equation is going to be, let me change it to x. X is equal to t. My independent variable is equal to the other independent variable. And then I'm basically going to write the parametric equation solve for y and substitute in t for x. In order to do that, I need to rearrange this equation here. 2x plus 3y equals 11. So to do so, I'm going to, you can do a few different things. I'm going to subtract 2x from both sides. So then I get 3y equals negative 2x plus 11, or you could do 11 minus 2x, either one. And then to isolate y, I'm going to divide everything by 3. So when I divide everything by 3 on the right-hand side, I'm going to end up with some fractions. Y is equal to negative 2/3. Remember, instead of x, I'm substituting in the other independent variable t to make it parametric. Plus 11 over 3 doesn't reduce, so I'm going to leave it as 11/3. So these two are the parametric equations for that. The next two questions, 24 and 25, I give you the parametric equations, and I need you to go backwards. Okay, so essentially, I give you two equations that are already solved for x and y, and if you're going to go backwards, then you need to solve each of these equations for t first. Solve them for t. So let's take the first one. X equals 4t minus 8. And if I want to solve this for t, I'm going to go ahead and add 8 to both sides. And then I get x plus 8 is equal to 4t. And then to isolate t, I'm going to divide both sides by 4. So here it cancels, and on this side I get this. So then I end up with the equation t equals x plus 8 over 4. Now you could write that as 1/4 x plus 2 if you wanted. There's nothing wrong with that, but I'm going to go ahead and leave mine like this. Then my next equation, the y, let me change colors. Y equals 3 plus t. If I solve this one for t, I'm going to subtract 3 from both sides, and I get t equals y minus 3. Since I have solved for t in both instances, in order to write the equation in slope-intercept form, all I need to do is set these equations that are both equal to t equal to one another. So if I do that, I'm going to have x plus 8 over 4 is equal to y minus 3. And then to write this in slope-intercept form, I just need to get y by itself. So you could do a few different things. You can add 3 to both sides, take care of the fraction on the left, however you want to do it. I'm going to go ahead and put my right side over 1 and cross multiply. So if I do that, I'm going to get x plus 8 times 1 is just x plus 8 is equal to 4 times y minus 3. So that 4 needs to distribute to both y and negative 3, giving me x plus 8 is equal to 4y minus 12. And then in order to isolate y, I'm going to add 12 to both sides. So then I get x plus 20 is equal to 4y. And then to isolate y, I'm going to divide both sides by 4. And then doing that, I'll get my final answer, y equals x plus 20 over 4. Now, at this point, in slope-intercept form, this is where we really do kind of want it in y equals mx plus b form. So that division by 4, we want to break up into two separate numbers. So as a final answer, we'll say y is equal to 1/4 x, or you could do x over 4, plus 20 divided by 4 is 5. Same idea for number 25. For this equation, I give you the parametric equation solved for x and y, and I want to know this in slope-intercept form. So if I take my x equation, x equals 3 plus 2t, I want to solve this for t, so I'll subtract 3 from both sides, and I get x minus 3 is equal to 2t. So then if I divide both sides by 2, I get the equation t equals x minus 3 over 2. Again, if you want to write that as 1/2 x minus 3/2, you can. It's just my personal preference to leave it as a stacked fraction. That way I can cross multiply after we set them equal. Second equation, y equals -1 plus 5t. To solve this for t, I'm going to add 1 to both sides. I get y plus 1 is equal to 5t. So to isolate t, I'm going to divide both sides by 5. So then t is equal to y plus 1 all over 5. Again, since I have two equations both equal to t, that means these two equations are then equal to one another. So we can set them equal and solve for y. So if I have x minus 3 over 2 equals y plus 1 all over 5, if I cross multiply, again, you just got to be careful with the distribution here. This is going to be x minus 3 in parentheses times 5 equals 2 times y plus 1. So that 5 and that 2 both have to distribute to both terms on the inside of those binomials. So that's going to be 5x minus 15 is equal to 2y plus 2. And then remember, the goal is to get y by itself. So from here, I'll go ahead and subtract 2 from both sides. Doing so gets me 5x negative 15 minus 2 is negative 17 is equal to 2y. And then to isolate y, we will divide both sides by 2. So again, you'd get y equals 5x minus 17 over 2, but in slope-intercept form, you really do want to go ahead and break that fraction up into two separate fractions. So that will be 5 halves x minus 17 halves as your final answer. Number 26 is a three-part problem. It says a line passes through the point at 11, -4, and it's parallel to vector A, which is at 3, 7. Write a vector equation of the line. We did this on number 22. So just to recap the vector equation, here this is something that you need to know. You do x2 minus x1, y2 minus y1. That vector is equal to the parameter t times vector A, whatever they give us there. So following that same equation, if I have these as my x and y coordinates, x1 and y1, and of course vector A, we have the numbers there, then as your final answer for your vector equation, we would say this is x minus 11, the vector x minus 11, y minus -4, which will change to y plus 4. So that vector is equal to the parameter t times vector A, which we know is 3, 7. So that is a formula, or an equation rather, that you will have to know for your test. Now, once you have this vector equation, if I ask you for the parametric equations, essentially what you're going to do is you're going to set the x terms in each of these vectors equal to each other and the y terms equal to each other. So the x terms will be x minus 11 equals, we're going to distribute that t into both of these. So it's going to be 3t. So let's do it in red. X minus 11 is equal to 3t. And then parametric equations are solved in terms of x and y. So then if I add 11 to both sides, I get the first parametric equation, x equals 3t plus 11, or it could be 11. Oh, what the heck happened there? 11 plus 3t, either way. There's a random t just hanging out here. There we go. X is equal to 3t plus 11. So there's the x parametric equation. For the y parametric equation, you're going to set your y sections equal of the vectors. Y plus 4 is equal to, again, we're going to distribute this t to that 7. So that's going to be y plus 4 is equal to 7t. And then to solve for y, we will subtract 4 from both sides. And we'll get our second parametric equation. Y is equal to 7t minus 4, or you could write it as negative 4 plus 7t. And then lastly, part C, it says to use these parametric equations to write the equation of the line in slope-intercept form. So this is just like question 24 and 25 that we did. If I have the equations for x and y, I'm going to solve each of them for t. Solve each of them for t. So if x is equal to 3t plus 11, to solve them each for t, I'm going to subtract 11 from both sides. I get x minus 11 is equal to 3t. So to isolate t, I'm going to divide everything by 3. In doing so, I get the first equation, t is equal to x minus 11 over 3. So I'm going to hang on to that equation. I'm going to do the same thing with the y parametric equation. Y equals 7t minus 4. And I'm going to solve this one for t as well. So I'll add 4 to both sides. I get y plus 4 is equal to 7t. So to isolate t, if I divide everything by 7, I get the second parametric equation solved for t, which will be y plus 4 over 7. Notice we have both of these equations are equal to t, which means the parts that I've just highlighted in yellow are also equal to each other. So if they're equal to each other, then we're going to set them equal. X minus 11 over 3 equals y plus 4 over 7, and then we need to resolve for y. So again, we can cross multiply. So if we do that, we get x minus 11 times 7 equals 3 times y plus 4. You need to be careful to distribute this 7 to both terms and this 3 to both terms. In doing so, we get 7x minus 77 is equal to 3y plus 12. And then we can go ahead and subtract 12 from both sides. So then we get 7x. Negative 77 minus 12 is negative 89 equals 3y. And then to isolate y, we're going to divide everything by 3, which 7 isn't divisible by 3, nor is 89. So your final answer would just be y equals 7/3 x minus 89/3. That is the equation in slope-intercept form. Number 27, find the horizontal and vertical velocity of an arrow released at 47 meters per second at an angle of 10.7 degrees with the horizontal. A picture will be helpful in this one. So if we have an arrow being released, we have a vector, something like this. It says that it is 10.7 degrees with the horizontal. If they use the verbiage with the ground, y'all, the ground is the same thing as the horizontal. So 10.7 degrees. Okay, the arrow is released at 47 meters per second. So that velocity is going to act as the magnitude of that vector. Okay, 47. The question is, what is the horizontal and vertical velocities of this scenario? Well, if I drop down this altitude, I have a right triangle. So I can solve for, well, that should be y, the vertical velocity, and x I can solve for the horizontal velocity using trig, using SOHCAHTOA. So if I set up cosine of 10.7 degrees, cosine is equal to adjacent over hypotenuse. So adjacent is going to be x. The hypotenuse is 47. So then x is going to equal 47 times the cosine of 10.7 degrees. I don't specify how to round for each individual question for the sake of just the rest of these questions. Let's just do to the nearest hundredth. In doing so, you get that horizontal velocity is approximately 46.18. It is a velocity, which means I need to continue my units of meters per second. So the horizontal velocity is 46.18 meters per second. Do the same thing to find the vertical velocity, except we're going to switch our trig function to sine, since it is y over 47. So then y is going to equal 47 times the sine of 10.7 degrees. So y is going to be approximately, again to the nearest hundredth, you should get about 8.73 meters per second. Now, 28 is very similar to this. Find the horizontal and vertical velocity of a cannon shell fired at 1,200 feet per second at a 42-degree angle with the ground. So this one's very similar. If we draw this scenario, we have 1,200 feet per second here at an angle of 42 degrees with the ground. So 42 will go here. And then it wants to know horizontal and vertical velocity. So we can put x for horizontal, y for vertical, and then proceed to solve. Now, if you get pretty comfortable with what we did for 27, you can kind of skip the first step. Instead of putting cosine is equal to adjacent over hypotenuse, you can start off straight with, kind of start off at this step 2 here, where x is going to equal the velocity of the object, in this case 1,200, times the cosine of the angle it makes with the ground, cosine of 42 degrees. Again, to the nearest hundredth, you should get about 891.77 feet per second. So again, if you're uncomfortable skipping this step, then go back to what we did for 27 and write like sine is equal to opposite over hypotenuse. Or if you're comfortable, when you basically cross multiply and you solve for y, you get that the hypotenuse, or the velocity of the object, 1,200, times the sine of the angle 42. And again, you'll get y is approximately 802.96 feet per second. Okay, our last question, number 29. Remember, we're omitting 30. Is a two-part question. Professional golfer Annika Sorenstam hits the ball with a force to produce an initial velocity of 175 feet per second at an angle of 35 degrees above the horizontal. She estimates that the distance to the hole is about 225 yards. Write the position of the ball as a pair of parametric equations. So that part is easy, and that's what you need to remember from your notes, is how to do that. So if I ask you to write parametric equations of that represent that motion, that's going to be x is going to equal that initial velocity of your vector. Ruh-roh, Raggy. I just deleted the whole paper. There we go. Okay, so that's going to equal the velocity of your vector times t times the cosine of the angle theta. And I don't remember if in your notes I put theta. In fact, let me go check to make sure that this is what we had. I didn't use any other angle here. For the parametric equation for y, remember y is up and down, so we have the component of gravity that is an aspect of that as well. Oops, it shouldn't be 16. It should be g. One half g t squared. Okay, again, let me go verify this really quickly that those are the equations that are in your notes. You need to know these equations off the top of your head. So those will not be given to you. You have to know how to write the parametric equations with that motion aspect to it. And it's pretty simple. The only part that you have to remember is for that y portion to subtract off the gravity component. Okay. Well, okay, in your notes, these were opposite. I put t times the vector v cosine theta, and I did put theta. Okay, so this is exactly what your notes say, so I didn't do any kind of variation there. These were circled in blue in your notes. You have to know these. Using that, if I look at the equation or the information that I'm given in the equation, x is going to equal the velocity that they tell us is 175 times time. We don't know what that is. That is remaining as a variable, so you keep that as t, times the cosine of theta, in this case the angle is 35 degrees above the horizontal. So your x parametric equation will be 175t times the cosine of 35. The y parametric equation starts off almost the exact same. 175 times t, except we change it. Y is the sine of 35 degrees. But again, y, your vertical movement of the golf ball, involves gravity. So from there, we're going to subtract 1/2 g t squared. Now, in this case, gravity, you have to pay very close attention. Gravity is either, let me write this over here. Gravity is either going to be 9.8 meters per second squared if you're in meters, or 32 feet per second squared if you're in feet. Well, notice we are given her velocity in feet, which is why we need to choose 32. So if I do 1/2 times 32 for gravity times t squared, I can go ahead and simplify 1/2 times 32. So my x parametric equation is ready to go. If I simplify this one more time, 175t times the sine of 35 degrees minus 1/2 times 32 is 16t squared. So this is the simplified version of the parametric equation. So that's part A. Part B is find the range of the ball. When it asks us for the range, I want you to interpret this as how far did she hit it? How far did she hit it? So this is not as simple as plugging in something for time. In fact, this question doesn't really have much to do with time at first glance. But it has to do with the path that the ball took. So if we remember that parametric equations take the shape of a parabola, right? If we imagine that the golf ball starts at the origin, she hits the golf ball, goes up in the air, and then it comes back down. Now, this is going to assume that the ball does not have any additional roll on it afterwards. We're going to assume that it plugs. Once it hits the ground, it stops. So if you look at this, if this is a parabola, think back to all of your other mathematical knowledge. These guys are called zeros, right? Or roots, where they intersect the x-axis. Well, the first root is just at a position of 0 and at a time of 0. But if this is distance versus time, then what I want to do is I want to solve for the second root, because that's where the ball lands. That's going to tell us how far it went. Well, it's not. It's going to tell us the time that it took for the ball to go that far. So let's do that first. I'm going to take my quadratic equation, which is of the y's, and I'm going to set it equal to 0 and solve. So instead of y equals, I'm going to have 0 equals, And then I'm going to switch the order, right? We have quadratics are x squared plus x plus 1, right? Or ax squared plus bx plus c. So I'm going to put my 16t squared term first, plus 175t times the sine of 35. And I want to, remember this is a quadratic because I have a square term, so I want to factor this and solve. Well, the first method of factoring we should try every single time is GCF. So if I take out t from each term, that leaves me with negative 16t plus 175. We took out that t, so times the sine of 35. And then to solve, so I don't have to like do any other factoring method, sum or product or anything. This is going to give me my two zeros right away. If I set each of these equal to 0, either t could equal 0, which we knew, right? That's the initial starting position. Or we need to figure out what does t equal if this whole thing is set equal to 0. So that's what we're going to do next. If we set that equal to 0, we're going to get negative 16t plus 175 sine of 35 equals 0. Well, if you subtract 175 sine 35 from both sides, remember guys, this is just a number. So you can get what that decimal is and then subtract it from 0. You'll get negative 16t equals, that decimal is going to be approximately negative 100.38. And then to isolate t, I'm going to divide both sides by negative 16. And then I'm going to get that time is approximately 6.27. So let's think about what this means. This point here is a time of 6.27 seconds. That's how long it took her ball to land. That doesn't answer the question. The question is, how far did she hit it? Well, if I know that that's how far, or that's how long it took my ball to, or her ball to land, as far as distance goes, I can plug this in to the horizontal parametric equation. Plug into horizontal equation, which is the one that is solved for x equals. So x equals 175t times the cosine of 35. Well, if I plug in a value of t of 6.27, then 175 times 6.27 times the cosine of 35 will give us a distance of approximately 899 feet, which seems like a lot, but for you golfers, this is in feet. So if you convert that to yards by dividing by 3, it's about 300 yards, which is average for about a drive. So that's your final answer. Now, if you're wigging out, you're like, oh my gosh, we never did one that complicated, and that was very long and strenuous, and I don't know that I'll be able to do that on my test. I will say this, the one on your test is not that challenging. The one on your test is more like some of the easier ones that we did in the notes and in the homework. I ask you for the parametric equation first, so part A will be the same, but part B is going to ask you more things like what was the horizontal, or what was the horizontal distance when the time was 5? Where you just plug in 5 into this equation, or what was the vertical distance when the time was 0.5, and then you plug in 0.5 to this equation. So it won't be as complicated as this one was.